Hi everyone, my name is William Lin. Here's a demo on native app with Snowpark Container Service. The container service also posts protected provider data through secure view shared to the native app. There are 3 Docker images we need to build in here: router, backend, frontend. Backend is Python with Snowpark code. Frontend is Node.js. These images build and deployed on the provider side. We have a GitHub workflow main.yaml. This workflow will run all bash script files and SQL files under deployment alphabetically. All the actions lay out the data structure on the provider side, including database, schema, image repository. Workflow main.yaml file. On the GitHub, it watches 3 branches, the dev, QA, and main. Any file changes under deployment folder will trigger this workflow. The deploy dev listening on the dev branch. It will pull all the environment variables from the dev to connect to the Snowflake. Let me show you the GitHub settings with the environments. So if you go to GitHub settings, you see all the environments listed. I have a dev which bound to the dev branch. It has 1 secret and 5 variables. Going back to the workflow main YAML, in the deploy step, it will look in this deployment dev folder, go through all the SH and SQL files one by one alphabetically, and run them using bash and SnowSQL. Let's look at each one of them. For this demo, all we really need is just this init file. It creates the database and the schema, and most importantly, the image repository. Image development is a big thing. There are constant changes on the backend, frontend, and different images. Each image has its own workflow and triggered by code changes in different directories. These 3 workflows are pretty similar. For example, the backend workflow. It monitors the backend folder changes. First, it makes the Snowflake connection, then calls build image backend script. And there are 3 script files here, one for router, one for backend, and one for frontend. Let's look at the backend. Here, using database name and schema name to show image repository. From there, gets repository URL. Snowflake CLI first makes a connection with image repository. Then the Docker login with the repository URL. Then Docker build. Then Docker tag. Push the new image to the tag. After provider image is ready, then we need to prepare the file for the native app. We have a README file for the consumer to use and the manifest file for native app installed on consumer account. In here we have container services consumer can use. These are the images from the provider account, and also the BIND SERVICE ENDPOINT for this native app. Setup script, a SQL file to execute when installing on the consumer account. It has the Snowpark Container Service procedures, starting the app and stopping and getting the URL to access the app. You can see the procedure in the SQL file. Start the app, stop, and getting the URL. To start the app, we need a specification file, which is the full stack YAML. You can see the container specifications in this file. Next is native app deploy. The GitHub workflow file is native app deploy YAML. If any file changes inside app's native app package, it will trigger this workflow. First, it makes the Snowflake connection and then run the sh file to deploy the native app. Here's the native app sh file. It will deploy the native app package using snow app deploy. Snow app deploy will deploy native app package. The native app package name is inside the snowflake.yaml. The snowflake.yaml file is used by the Snow CLI. If you're not using the Snow CLI to deploy native app, you don't need this file. So the name is the identifier. Manifest. This YAML file is the configuration setting on how to set up native app on the consumer side. So in here, it points to a setup script SQL file. This is the file to execute when we deploy the app on the consumer side. The consumer README file. After deploying native app package, we create a secure view used by this native app. This is the SQL file to create a secure view. This view is connecting to the provider database. This needs a reference usage because we use using a table from a different database, and we're granting this view to the native app package. Going back to the .sh file, after we're creating the secure views, this line here is creating a version 101. The good thing is it will create new patch every time this gets run. Inside this sh file, we also have this snow app run. It's create a local native app from the app package using the latest batch, which created from the line 10. If we go back to the snowflake.yaml, this is the app. It's creating from this package, and this will be the local app name. As I indicated here, snow app deploy. We'll use snowflake.yaml for deployment. It's not needed if you're not using Snow CLI. It will create a stage automatically, defined it in the Snowflake YAML stage. This process will perform a diff on file changes on the stage to determine if redeploy is needed. Consumer can access the app through Snowsight, data products, apps, and the app name. In the manifest file, this native app requires a privilege need to provide by the consumer, BIND SERVICE ENDPOINT. So when the app is open, go to privileges. Consumer can grant this privilege to the app. There are two types of warehouses needed here: a query warehouse and a compute pool, which is used by the container services. These two queries create a query warehouse and a compute pool for the containers, and then grant the usage on these warehouses to the native app, plus grant BIND SERVICE ENDPOINT to the native app. Here we have a startup procedure to start the container services based on the specification file. When we run this procedure, it will indicate service started, check status, and when we try to get URL, endpoint provision in progress. Check back a few minutes. Let's try again. Finally, we get a successful URL. Alright, here's the front end with data from the provider side. And let's go back to the queries, and we can see the services. The service is running. If we want to show the service containers, we can see there are 3 of them: the backend, front end, and the router. And now we can stop them and show the service again. Now they're gone. Publish. Once native app is tested locally, ready for the public or consumer accounts, we do publish. What we need is set the right version for consumer to use. Here's the workflow for native app release. This does not trigger automatically. It allows manual trigger from the GitHub Actions tab. Here are the steps: connecting to the Snowflake and then run a SQL file here. Release latest patch SQL file. In this SQL file, it will pull the latest patch from this version 101. Once it has the latest patch and use that patch number to set the default release directive. Once this is set, the installed consumer app will get upgraded. For consumer to use, we do need to publish it. Go to Snowsight, data product, provider studio, and create listing. From there, we can select internal marketplace or select the consumer accounts.